I'm just going to use this video to review some of the frequently missed questions from your first test of the second marking period. One of those questions was number 7. The value of the discriminant is negative if you have no x-intercepts. So using that idea, the answer is choice 4. Keep in mind that the formula for the discriminant comes from the quadratic formula. It's b squared minus 4ac. You don't need that for this problem. But if they asked you something different, like which graph represents a quadratic function with a positive discriminant, that would mean that you have 2 x-intercepts. And if they said which graph represents a function that has a discriminant equal to 0, or b squared minus 4ac equal to 0, that would mean you have 1 x-intercept. So here, the value of the discriminant is positive because you have 2 x-intercepts. Here, the value of the discriminant equals 0 because you have 1 x-intercept. And in choice 3, the value of the discriminant equals a positive number because you have 2 x-intercepts. The next question that was frequently missed was question 8. A lot of you got it down to the right 2 choices, but you forgot to do end behavior. If we look at question 8, the zeros that you have are at x equals -1 and x equals 2. -1 as a 0 is x equals -1. If we add 1 to both sides, we can write it in factored form. So as a factor, that 0 is represented as x plus 1. For x equals 2, if we set that equal to 0, we have the factor x minus 2. So if we were trying to write this as an equation, f of x would be equal to x plus 1 times x minus 2. And now we need to incorporate the type of 0 with the end behavior as well as the multiplicity. Right here, x equals -1 goes straight through. So the exponent on that 0, or the factor of that 0, should be 1. Right here, our graph bounces right off of the x-axis. So that means we have a multiplicity of 2. A lot of us chose the choice that corresponded for x plus 1 times x minus 2. However, this graph is that of a negative odd function. Odd because the ends go in opposite directions, negative because of the behavior of the graph. Remember, if the right side is going down, the graph is negative. Another question that was frequently missed was number 11. If you look at 11, the degree of the function is 3. Since the degree is 3, that means that there is going to be 3 solutions. Now, we've learned that real solutions are solutions that cross the x-axis. So we have 1 real solution. If there's supposed to be 3, that means we've got some imaginary solutions. If one of the solutions is real, that means that 2 must be imaginary, because the total solutions is equal to the degree of 3. Question 14 was a review question, and in that question you had to keep in mind that 5 is really 5 over 1, and we need a common denominator in order to do anything. So now, our denominators, in order to be the same, require a little manipulation. The denominator on 5 needs a 3x in order to be the same as the first denominator. And the denominator on 4 requires a 3. So whatever we multiply the denominator by, we have to multiply the numerator by. Once all the denominators are the same, we can cross them out, and we are left with 2 plus 15x equals 12. Regular solving by subtracting our 2 on both sides gives us 15x equals 10, or x equals 10 over 15. That's acceptable. 2/3 is acceptable. Or some of you even wrote it as 0.6 repeating. Whatever you want to write is fine because it doesn't say to reduce your answer or to express your answer in simplest form. 16 was a question that I think a lot of you guys could do, but because of the way it was set up, confused us. Now, remember, whenever you're asked to solve something, you have to set it equal to 0 first. That's what caught us up. So if I subtract 2x and add 4, I can set this equation equal to 0. Now, if I try to factor, I'm not going to be able to think of anything that multiplies to 4 and adds to 2. So my options are the quadratic formula or complete the square. If you use the quadratic formula, the formula will be provided to you on the day of the Regents in the classroom. It's hanging up on the front left of the smartboard. You're going to plug in your A, B, and C values. Once you do that, use your calculator to clean up what's underneath the radical. If you do that, you're going to get 2 plus or minus negative 12 under the radical all over 2. Remember, when you're simplifying, the square root of negative 12 becomes I times radical 4 radical 3, or 2I radical 3. So this answer is 2 plus or minus 2I radical 3 over 2. Notice the division bar is underneath both of the terms in the numerator. 2 divided by 2 is 1. 2 divided by 2 is 1. You still have an I and a radical 3. If you don't like that, then what you could do is solve it by completing the square. If we solve by completing the square, we have x squared minus 2x plus 4 equals 0 again. The magic formula for completing the square is not given to you. It's half of b squared, so it's something you need to know. And the way we set this up is we do x squared minus 2x, space, plus 4. In those spaces, we are going to evaluate half of b squared. The b value being 2, half of 2 is 1, 1 squared is 1. So I'm going to add 1 and subtract 1. Complete the square allows us to create a trinomial that can be factored and a constant term. Once your factors are done, they should be the same. You have x minus 1 squared plus 3 equals 0. Subtract 3 on both sides, and you get x minus 1 squared equals negative 3. Take the square root. X minus 1 equals plus or minus. The negative becomes an I. Keep the radical on the 3. It's not a perfect square, and it can't be simplified. And then just add 1 to both sides. So you get the same answer as we had with the quadratic formula. If I didn't go over your question, come to Extra Help.